As the question says, 6 particles situated at the corners of a regular hexagon of side A moves at a constant speed v. Each particle maintains a direction towards the particle at the next corner. Calculate the time the particles will take to meet each other. If we draw the diagram of this question, this would be almost like this. If we assume this to be A and this to be B and C respectively. Now, let us first understand this problem. In this problem, it is like at the initial moment A will be heading towards B, B will be heading towards C, C will be heading towards D. Now, at the second moment, they will be a little ahead. At that point, A will be heading towards B at that time. B will be heading towards C at that time, and C will be heading towards D at that time. Now, what will happen eventually will be that they all will follow and fall over here. Everyone will go like this. And eventually they will meet at the center of this hexagon. So it's very much easy to solve this problem with the relative concept. If we see relatively, then A is following B and it is only covering the distance between A and B. It doesn't matter in the relative concept that where and when do they meet. Yes, they meet at the center after a long time when they both covers that distance, this curvature. Now, if we look at with the relative concept, we can take one of the edges like this. We always know that the exterior angle for the regular hexagon is 60 degrees. Assuming this to be A and this to be B. Notice we are taking this one and we have taken A and B over here. And taking the velocities like this, we can find out the velocity of A with respect to B, which will be obviously velocity of A minus velocity of B, and that will be, notice that these are all the vector quantities, so we need to minus them accordingly. So we get it as V equals to now V minus V cos 60 degrees, giving us V by 2. This means that A is approaching B with a velocity of V by 2. Now, what is the actual distance between A and B? This is the side A because A and B are the corners. So, actually, in the relative concept, they need to cover this distance with this velocity, which can give us the time as distance upon velocity, that is A upon V by 2, giving us 2A over V.